Gemini 3.6 Flash is officially here, and the useful story is not simply that Google shipped another faster model. In Datacurve's DeepSWE version 1.1 snapshot, the new Flash reaches 48.6% pass at 1. The published 3.5 Flash row is 37.4. Mean cost falls from $7.34 to $3.53, while output tokens fall from roughly 276,000 to 97,000. That is an 11-point quality jump with about half the cost. But the model also takes more agent steps, which makes the efficiency story much more interesting than one launch bar. First, keep the benchmark contract attached. DeepSWE version 1.1 contains 113 software engineering tasks across 91 repositories and 5 languages. Datacurve runs the models through mini-swe-agent, repeats the whole benchmark 4 times, and reports a run-to-run interval. For Gemini 3.6 Flash at high thinking, that interval is about plus or minus 5 percentage points. A task receives binary reward, so one missed acceptance check can turn a nearly complete patch into a 0. This is valuable because it resembles real delivery. It is still one harness, one task set, and one operating configuration. Now open the economics. Compared with the published Gemini 3.5 Flash Medium Row, 3.6 Flash High uses about 65% fewer output tokens, costs about 52% less, and finishes about 20% faster on average. Yet it uses roughly 26% more agent steps, 108 instead of 86. That suggests a model taking more, shorter, cheaper turns rather than merely quitting earlier. It also warns us not to treat tool call count as a universal efficiency metric. These are 2 official rows with different thinking labels, not a clean ablation. The production question is whether the entire delivery gets cheaper while acceptance improves. The aggregate gets texture when we open a task. On TS pattern matchEach, all 4 published Gemini 3.6 Flash attempts received reward 1. The rollout we selected took 42 agent steps, produced 56,174 output tokens, and cost $1.12 in the published accounting. Its patch added a matchEach matcher that evaluates every matching clause and returns the results in order. The verifier reports 85 of 85 feature checks and 6 of 6 regressions passing. 4 passes in 4 attempts on one task is not whole benchmark reliability, but it is a stronger artifact than a single lucky green cell. We then tested the artifact without pretending to rerun the model. The repository was pinned to Datacurve's recorded TS pattern base commit. We applied the frozen public model patch, restored the published test patch separately, installed the locked dependencies, and ran the declared helper and matchEach jest suites. Both pass locally. That means the published patch applies cleanly and survives the tests in this environment. It does not mean Gemini would regenerate the patch on demand, and it does not create a new pass at one estimate. Local reproduction narrows one uncertainty: the passing artifact is executable evidence, not just a screenshot. Now the retention reset. On an HTTPX multi-part response task, another Gemini 3.6 Flash rollout passed 121 of 122 feature checks and all 1,272 regression checks. That is 1,393 green checks and 1 miss. Binary reward 0. This is not proof that the benchmark is unfair. It is proof that last-mile acceptance dominates deployment. A patch can preserve every regression, solve almost the entire requested feature, and still fail the contract. If your evaluation reports only average partial credit, you can hide exactly the kind of edge case that blocks a merge. What are you actually buying? Gemini 3.6 Flash is generally available under the stable model ID Gemini 3.6 Flash. Google documents a 1 million token input limit, 65,536 output tokens, multimodal input, thinking, code execution, search grounding, and computer use in preview. Base list pricing is $1.50 per million input tokens and $7.50 per million output tokens. Google also made it the default behind its anti-gravity managed agent. Those product facts help explain the intended use. Fast, repeated agent loops with enough context for real repositories. The migration has sharp edges. For 3.6 Flash and future Gemini releases, Google deprecates temperature, top P, and top K. Numeric thinking budgets become named thinking levels such as medium or high. Candidate count is unsupported in Gemini 3 models. Requests ending in a pre-filled model turn are rejected, so applications that used a trailing model prefix to suppress preambles must move that instruction into system guidance or structured output. Pin this behavior in contract tests before switching an agent fleet. A cheaper model that returns 400 on the first request is still an expensive migration. The verdict is strong but bounded. Gemini 3.6 Flash shows a meaningful DeepSWE quality jump and a dramatic reduction in output tokens and mean cost. The passing TS pattern artifacts survived local reproduction, and the HTTPX near miss shows why hidden acceptance tests still matter. Give 3.6 Flash several representative tasks from your own repositories, pin the harness and thinking level, run multiple attempts. Keep tests outside the agent's edit surface. Track wall time, retries, review minutes, unwanted edits, and total spend per accepted delivery. The best reason to adopt this model is not 49% on a public chart. It is evidence that the whole engineering loop can become cheaper without lowering the bar for correct.